Hey guys, a couple students had a quick question about alkylation of alkynes, and so I pulled some OWL questions out in order to better help explain to you guys what alkylation is all about. So in normal alkylation, what we have is this NaNH2 molecule, and this NaNH2 molecule is this really strong base, and it's gonna want to pull the hydrogen off. And so if I were to draw a mechanism for this, I would draw this NaNH2 molecule going towards this hydrogen, and the carbon hydrogen bond breaking, and the electrons would be going to the carbon. Ultimately, what happens is you end up with this molecule right here. You end up with a molecule like this. You have a carbon bonded to a triple bond, carbon triple bond carbon, hydrogen off to the right, and since this carbon is getting the electrons, this is going to have a minus charge. And so this step is done. This NH2, NH3 step, it's done. Now you have a 4 carbon attached to a bromine. So that looks something like this. 1, 2, 3, 4. Like this. 1, 2, 3, 4, and then a bromine. And so remember when we talked about nucleophile always attacks the electrophile? What happens in this mechanism is this nucleophile, this has a minus charge, so it's a nucleophile, it's electron rich. It's going to attack the electrophile in this manner, and it's gonna attack the carbon that's attached to the bromine, and this carbon bromine bond that you see right here, this bond is going to break. And so if I draw this in blue, the electrons are going to go to bromine. And bromine is a really good leaving group, so it's going to want to leave. Now what you end up with is a molecule that looks like this. You have this carbon triple bond, and there's still that hydrogen over there. And now you have 1, 2, 3, 4 carbons that you're adding to that carbon triple bond. So here's carbon 1, carbon 2, carbon 3, and carbon 4. And so I could just draw them in like this. If I make this 1, carbon 2, carbon 3, and carbon 4. And so this is going to be your final product right here. You have this carbon triple bond, and then carbon 1, carbon 2, carbon 3, and carbon 4. And alkylation simply means just increasing the amount of carbon bonds that you have in your molecule. You can see over here you only have 2 carbons, and over here in the final product you're going to end up with 6 carbons. Over here you can see 1, 2, 3, 4, and then 5, 6. And then you can use all the reactions of alkynes to this molecule right here. Taking a look at this example, this is the question that someone had in particular. What are you supposed to do if you don't have a hydrogen that can be pulled off? Like over here in the previous example, this hydrogen was pulled off, and that made a good nucleophile. What can you do in this situation? The answer is you can't do anything. Since there's no hydrogen to pull off, look, there's a carbon here, and there's 1, 2, 3, 4 bonds on this carbon, so it's only a carbon. There's no hydrogen. And likewise, there's only a carbon over here. You can't do much. And so this reaction is going to have no reaction because there is no hydrogen that it could pull off. And so I think in OWL, if you draw this structure, you'll be all set. So moving on to this example right here, draw the organic products of the following reaction. Over here you could see you do have a hydrogen that can be pulled off. Now you have to think about what's doing the pulling action, what's pulling it off. What is my base? And so NaOH in H2O. NaOH H2O usually has a pKa of around 16. On the other hand, this alkyne molecule right here has a pKa of 25. Now we have to think, this is our acid, this is our base. Which one should we need? Ultimately, if this carbon-carbon alkyne, we need a base that is a lot higher than this pKa, because if you guys remember, bases, the higher the pKa, the stronger the base. But this doesn't make sense right here. This pKa is more it's a lower number than this 25. So it can't really pull off this proton right here. It's too weak of a base to pull off this hydrogen. And so just like the last example, this is also going to be no reaction. Think about it like this. If you have a very acidic molecule right here, and this pK is 25. And if you have a base like NaNH2 with a pKa of around 40, then it's easily going to be able to take this hydrogen away. In this case, if this has a pKa of 16, it's not really going to be easy to take this hydrogen away, and that's why no reaction is going to occur. Moving on to this example here. This is a classic example of alkylation. And so remember what we did in the first example. NaNH2, very, very, very strong base, very good base. It can easily deprotonate an alkyne. So what's going to happen is this NaNH2 is going to take the hydrogen away and break this carbon-hydrogen bond. What's going to ultimately form is something like this. And since this gets the electrons from the hydrogen, it's going to be a minus charge. Now you have this second step. It's going to look something like this. 1, 2, 3, 1, 2, 3. And then the bromine. Let me just make sure I have the same carbons. 1, 2, 1, 2. This central carbon here. And then 1, 2. This is why it's important to make sure you guys have the right amount of carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, perfect. So what's the nucleophile? We always have to ask ourselves, what's going to do the attacking? What's the nucleophile? The nucleophile is going to be this. And this is going to attack what? It's going to attack the carbon-bromine bond. More specifically, it's going to attack the carbon that's attached to the bromine. So it's going to come over here. It's going to attack this carbon. And then this carbon-bromine bond is going to break. In the end, what you have is something that looks like this. You still have this base structure, this CH3, CH2, bonded to a C, triple bond. You still have that C, but now you have to look at this. You have to start on this side. So this will be 1, 2, 3, and you can make this 4, and then this is the subunit of 3. And so I could draw this in like this. So this is still that C. Make this a 1, 2, 3, 4, and then this is the subunit that I was talking about. So you're adding 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons, just like that. And this would be the final product. I hope this video helps. If it doesn't, anytime, feel free to email me. My email is this@wayne.edu. Or you could even feel free to text me anytime. This is my number. 416-3516. 248-416-3516.